we've already come across the Scalar triple product. It looks a little bit like this. We've got A, let's use a black pen here, A dot B cross C. So 3 vectors, and the scalar triple product of those 3 vectors is A dot product B cross C. And we've also discovered that there's only one way can be calculated, so we do B cross C first, and then we dot it with an A. The answer is a scalar, so we don't get a vector. We get a vector when we do B cross C. So we do that first, and we get a vector, and a vector dot product another vector gives us a scalar as an answer. And we've also seen that if we've got B and C, 2 vectors here, and we've got A up here, that it can be considered that the scalar triple product will be not the area, but the volume of the parallelepiped formed by those 3 vectors A, B and C. So B cross C, the magnitude of that would be the area of the parallelogram formed by B and C. And then when we do the dot product, we actually get the volume of that. Now, it's quite cumbersome to be able to calculate, but now we've got things in component form, it makes it very, very easy. And without proof, I'm just going to state and show you an easy way to actually calculate it. So if we want to calculate the scalar triple product, it's using matrices again, just like we did for the cross product. So it's the determinant of a matrix, and it'll be a 3 by 3, and all you have to do is to write down the components of the first vector. Let's just say there are A1i, A2j and A3k. The component ij and k components of the B will be B1, B2, B3, and C will be C1, C2 and C3. So A1, A2, A3 are the ij components of vector A, B and C, etc. And just to go over it again, the way to calculate the determinant of a 3 by 3, we put plus, minus and plus, and we put A1, the determinant, now that wipes out that and that, so B2, B3, C2, C3, minus A2, B1, B3, C1, C3, plus A3, so we've done this before, A3, B1, B2, and C1, C2. And then to do the final calculation, A1, do the leading diagonal, B2, C3, always minus the product of the other diagonal, C2, B3, minus A2, outside of B1, C3, minus C1, B3, plus A3, B1, C2, minus C1, B2. So given all of these components here are just numbers we can calculate, certainly there are no vectors involved anymore. So this certainly is a scalar as an answer. And that would actually constitute, when you work that out, it would be the volume of that parallelepiped.